In this video, I will try to walk you through the analysis of program flow and try to help you better understand labels in an assembly program in RISC-V. I pick a question that was in the midterm exam for the fall of 2019 offering of 229. The question asks that the student write two functions. So there is a question 5, and sorry, they are out of order in the slides, but the question 5 is asking the students to write a question called a function called reverse string. And then the question 6 is asking the students to write a function called reverse all. We're going to go straight into the solution of the question because we are most interested in this video about how the flow of the program happens. So what would happen when these functions would be executed is that there will be a main function. Every program that gets executed has a main function. So at some point, the assembler or the simulator will have a jump and link instruction to the main function. And then in the solution for these questions, we have a function that's called reverse all. And notice that the main function has at line 11 a JAL or jump and link instruction to the reverse all. And then the reverse all function calls the reverse string function. So those are the two functions that would have been written by the students as a solution to that question in that exam. What I want to do in this video is to walk you through the flow of the execution of the program, and hopefully doing that help you better understand how labels work in assembly. So the function main would eventually be called by the simulator that's executing this program, or in a real machine, the operating system would be jumping to the label main to execute the program. And as we execute the program, eventually we get to line 11. Line 11 has a jump and link instruction. Note that this jump and link instruction does not have the array and such that we showed in class. This is a pseudo instruction in RARS. And if you look at the instruction that actually gets generated in RARS, it will be the jump and link with the array coded in there. But this jump and link function is a function call. And when it's executed, what will happen is that the flow of control of the program will be changed to the place in the program that contains the label reverse all. And the label is always associated with the next instruction after the label. So this label is also referring to the address of the add I instruction, which is the first instruction in the execution of this program, of the function reverse all. So at that point, the execution will be transferred to the reverse all function. And because there is no flow of control instruction after the add I, the execution will follow sequentially until it finds a branch equal instruction at line 37. So there are two paths that can be followed from the branch and equal instruction now. We may go to the label do all, or we may continue execution the next instruction after the branch. Here's the label do all. So let's first follow the path of execution where we do the branch equal is taken, which means that A0 is equal as 2. And we go to execution to execute the instruction that is at the label do all. And as I said before, a label is always associated with the instruction that comes immediately after the label. The instruction could be that's connect the label could be in the same line as the label, or you could have several comments or blank lines between the label and the instruction. What you're looking for is the next instruction that comes after the label. So in this case, is the load word instruction. That load word instruction will be executed, and all the instructions that follow the load word would be executed, and eventually would get to the return statement that is the jump and link return statement that specifies that we're going to return to the address that's in array. Well, which is the address in array? The address that's in array is the address that was put in array when the jump and link at line 11 of main was executed. At that point, the address of the instruction that immediately followed that jump and link instruction would have been put in array. And at this point, it would be in array. What happened during the execution of this function is that I saved that value of array in 12SP, and then I restore at line 49 from 12SP to array. So array contains the address of the instruction immediately after that, that call to reverse all. So at this point, the execution of this return statement will return to that point, and that will be the end of the execution of the reverse all instruction, reverse all function. Now, of course, we only took one path from this branch and equal branch at line 37 of reverse all. There's another path that could be taken. That's when A0 and S2 are not the same. And that would lead to the execution of the instructions immediately below that instruction. And eventually we'll get to another jump and link instruction. That is the jump and link to the reverse string function. So at this point, the value of array would change, and the value that would be put in array is the value of the instruction add I at line, the address of the instruction add I at line 41 in reverse all. So we're going to be looking for the reverse string label now, which is at line 61. And the execution will now transfer to that point in the program, exactly to the instruction branch equal, that is the first instruction after the reverse string label. And immediately that is a branch instruction, and there are two possibilities. We may take the branch, which means that we'll go to the place where the done string label is. And if you analyze that path first, it means that we're going to go from the branch equal to the done string. The done string is a return statement that says, go back to the place that is, whose address is an array, in which case is the instruction at line 41, right below the function call. And then instruction will, execution will continue with the subsequent instructions until it gets to the branch not equal at line 44. And here again, there are two possible paths. I may continue the execution down if the branch is not taken, which will lead me to returning from this function, or I may go back to next string, which is up there. So this is a loop code where I go back to the next string. I get to next string, I will again execute a new call to reverse string. And I may keep repeating this loop many times until the termination condition of the loop is met. So I come to reverse string, and in reverse string, the first time I went to reverse string, I only look at one possibility for the branch in equal that I found in line 62. There's another possibility is that I'll continue execution. I'm not going to take this branch, and I'm going to get to another branch that's also also jumping to done string. And at that point, I may jump to done string. That's one possibility. Or I may continue execution until I get to the branch that may take me to next swap, which is the label that's up there. If this branch is taken, I'm going to go back to next swap, and I'm going to be executing a loop in this code here. The other possibility is that I don't know the condition of the loop, and I follow straight down to the done string label, to the instruction, to the return statement, and I return to this point of the call. So I wanted to give you this brief explanation of how the flow of control works in the program, because my sense is that if you're confused about labels, the problem are not the labels. The problem is that you are not looking at the program as a flow. And looking at the program as a flow will help you understand what's going on with the branches and the labels. Now, a question that I have gotten repeatedly is which label is a function and which label is not a function? Well, clearly in this example, there are only two labels that are functions, That's the reverse all, because it's the target of the jump and link instruction at the line 11 of main, and the reverse string, which is the target of the jump and link instruction at the line 40 in this code. There are no other labels that are target of jump and link instructions. So unless a label is the target of a jump and link instruction, the label cannot be a function. I know that can be a bit confusing because when we do a regular jump, we also use the jump and link instruction, but we use the register 0 to indicate that that jump and link is not linking, it's just a jump. And as a convenience for you, RARS allows you to use just the jump instruction, just a J instead of the JAL with the 0, which makes the notation simpler. I hope that this explanation helps clarify what is happening with the labels. I will stop sharing now and end this video.